The conductivity of materials varies. This means that electric charges pass through some materials more readily than through others. The tendency of a substance to resist the flow of an electric current is known as resistance. The unit of measurement for resistance is ohm, and the symbol for it is omega. The resistance of materials varies. Copper is a highly conductive element with low resistance. Nichrome is about 80 times more resistant than a piece of copper of the same shape and length. In some situations, the same substance may vary in resistance. This circuit is composed of a dry cell, an ammeter, a light bulb, and a nichrome wire. An electric current flows from one end into the nichrome wire, out through the sliding contact on the other end, and then through other components to form a closed circuit. Change the position of the sliding contact, and the length of the nichrome wire in the circuit is changed. When the sliding contact is moved to increase the length of the nichrome wire, the ammeter reading reveals that the electric current is smaller. On the other hand, when the length of the nichrome wire in the circuit is reduced, the ammeter reading goes up, showing that the electric current is larger. From this experiment, we can deduce that when an electric current flows through a substance, its resistance increases and the electric current passing through it decreases as the length of the substance changes. There's a metal wire in this closed circuit. If the wire is replaced by a thicker one made of the same metal, the ammeter shows a larger reading and the light bulb is brighter. This is similar to the situation in which a thick water pipe, where water flow is greater than in a thin pipe, or a wider road carrying a greater traffic flow than a narrow road. From this experiment, it can be deduced that resistance and electric current decreases and increases as the diameter of the substance changes. A rheostat is a component that allows us to vary the resistance. Place a rheostat in a circuit. When the rheostat is adjusted, the reading of the ammeter and the brightness of the light bulb vary. By changing the resistance, a rheostat increases or decreases the electric current in a circuit. The resistance can be changed by moving the sliding contact. The insulated coil in the rheostat is a resistant coil. When the sliding contact is moved to the right, the electric current first goes through the copper rod and then through the resistant coil. As the electric current is flowing through just a small portion of the resistant coil in the rheostat, the resistance in the circuit is relatively low, resulting in a large electric current. If we move the sliding contact to the left, the electric current flows through more of the resistant coil. The resistance in the circuit is increased and the electric current becomes smaller. If we move the sliding contact to the far left, the electric current flows through the rheostat's entire resistant coil. Here the resistance in the circuit is at its maximum and the electric current is smallest. The dimmers in household appliances, theater stage equipment, and control consoles make use of such varying resistance to adjust brightness and volume.